Evaluate these expressions. What we're going to do today is expand this, our understanding or knowledge of the trig functions. So we have sine of 3 pi over 4. We know that the reference angle here is pi over 4. Sine of pi over 4 is square root of 2 over 2. And then we say 3 pi over 4 is in the second quadrant. And in the second quadrant, sine is positive. So this is positive root 2 over 2. Very similar here, but now we have a fraction, 1 over 240. So we're going to say 1 over sine of 240 has a reference angle of 60 degrees. So the sine of 60 degrees is square root of 3 over 2. 240 is in the third quadrant, so it's a negative. And we will flip and multiply, so we'll have negative 2 over square root of 3. And we rationalize that to get negative 2 root 3 over 3. Similarly, we have 1 over tangent. Now, we can do this several different ways. We could say that this is 1 over the sine of 5 pi over 6 divided by the cosine of 5 pi over 6. Notice that the angle goes with both the sine and the cosine. So we have sine of 5 pi over 6 over cosine 5 pi over 6. And that is we can flip and multiply again. We have a cosine of 5 pi over 6 divided by the sine of 5 pi over 6. We're dividing by this fraction, so we flip and multiply by cosine over sine. And we get this. Now we got to say what's the cosine of 5 pi over 6? Has a reference angle of pi over 6. So it's square root of 3 over 2 over 1/2. It is in the second quadrant. The x value is negative. The y value is positive. So this simplifies to negative square root of 3. The next one, find the reference angle. This should be pretty straightforward at this point. We can take a quick look. We're going to go to 285 degrees. That's going to put us past 270, so we're in the fourth quadrant. So our reference angle here will be 360 minus 285, and that would be 75. So we say sine of 75, and now we determine are they the same or opposite. In the fourth quadrant, sine is negative, so we put negative sine of 75 degrees. Cosine 2, it just says 2, so what is the unit of measure there? It's a radian. So remember, we have, for looking at a unit circle, or any circle, a radian is the radius mapped onto the circle. So we have 1, 2, that puts us in the second quadrant. Our reference angle is going to be pi minus 2. So we'll say cosine of pi minus 2. And what is cosine in the second quadrant? It's negative. Remember in the first quadrant, this angle here, even though it looks ugly, is going to put us in the first quadrant. It's going to be something less than pi over 2 or 90 degrees. Okay, that's all for that review. And then we're going to start defining some new things here. If I give you this angle, here's theta, we have r, and we have some point x comma y. You can write, here's a definition. The sine of theta, we already know in a unit circle would just be the y value. And when we have a radius that's not 1, a simple way to see it, and I'll draw this, although it applies always if it was in the first quadrant, and this is theta and r, and there's y and x, we could say sine is opposite over hypotenuse, and that's what it is always. Cosine would be the adjacent, and we can deal with the reference angle, and as long as we take into account if it's positive or negative, these always work. And then the tangent is opposite adjacent. And on this case, x cannot equal 0. Now we already know as well that this can be written as the sine of theta over the cosine of theta. Now I'm going to do this just a little differently. Cosecant is 1 over the sine of theta, and that's going to be r, so in other words, the reciprocal of sine, so it's going to be r over y. And over here, y cannot be 0. Secant is going to be 1 over the cosine of theta, so that will be r over x, and x cannot equal 0. And then cotangent can be written as 1 over tangent theta, which is the same thing as the reciprocal of tan, or cosine of theta, over the sine of theta. And in terms of our letters, it could be written as x over y, and here y cannot be 0. So all the trig functions can be related back to our sine and cosine. And at this point, we're going to just apply these same ideas that we know to these new trig functions. 290 degrees. We're going to go around. We go past 270. We find our reference angle, 360 minus 290, and that gives us 70 degrees. So we'll write cotangent, just rewrite the trig function, 70 degrees. Now we look. In the fourth quadrant, what is cotangent? Well, cotangent is cosine over sine, or x over y. The cosine value, x, is positive, and the sine value, the y, is negative. So a positive divided by a negative is negative. So we'll just put negative here. Secant of negative 105 degrees. So we go negative 90, something past there. Our reference angle this time will be 180 minus 105, so we'll get 75. So we'll write secant 75 degrees. In the third quadrant, secant's 1 over cosine. In the third quadrant, cosine is negative, so secant is negative. Wherever cosine's negative or positive, those are the same places that secant will be negative or positive. Cosecant 600 degrees. Well, you can see that that's going to be more than 360. How much more? We got to keep on going. We can subtract 360 from there, and we'll get 240. So that's going to put us in the third quadrant. A coterminal angle is 240, so our reference angle would be 240 minus 180, or 60 degrees. So we will write cosecant 60 degrees. Now, in the third quadrant, what is cosecant? Well, cosecant is 1 over sine. In the third quadrant, sine is negative. So 1 over a negative is negative. And the last one, tangent, as far as these problems go. What's the unit of measure again? Yes, it's radians. So we're going to come over here. When do I stop? We know half a circle is pi, which is a number, 3.14. So we have something like this. And what's that angle? That reference angle is just pi minus 3. That's the exact value. I want you to use that instead of some approximation. And we have tangent of pi over 3. Now we have to determine, is tangent positive or negative in the second quadrant? Well, tangent is sine over cosine. Sine is our y value. The y value is positive. The cosine is our x value is negative. A positive divided by a negative is negative. And so really, there's no significant difference for doing those things. You just have to remember which ones go with which. Here's one way to take a look at this. If you look at the first letter, some people like this, so I'll point it out. The first letter of each of these, the hardest one, cotangent, is pretty straightforward. Most people know, okay, that's going to go with tangent. But people will get the cosecant and secant mixed up. If you look at a C goes with S and S goes with C, so there's no way a C can go with a C. Cosecant cannot go with cosine. Cosecant always goes with sine. It's a reciprocal of sine. And secant goes with cosine. The S goes with the C goes with the S. All right, let's take a look at graphing here. Now what we're going to do here first is say that y equals 1 over cosine of x. Let us make a table of values. Instead of using everything, well, let's start. I'm going to use some key numbers here, and then we'll talk about them. Trying to limit making too big of a table. So we have 1 over cosine of x. 1 over cosine of 0 would be 1 over 1. And 1 over 1 would be 1. 1 over square root of 2 over 2 would be two over root 2, which will reduce to the square root of 2. 1 over 0 is undefined. 1 over negative square root of 2 over 2 will give us negative root 2. Just maybe I'll show this one of these. 1 over root 2 over 2 gives us 2 over root 2. We rationalize that to give 2 root 2 over 2, and that just gives us square root of 2. There you can see it. And then 1 over pi would be 1 over negative 1, which would be negative 1. Now, so I'm doing this stuff here to help us get some values.